Where would be the most logical place to look in the sky if we wanted to find the closest planet outside our solar system? Naturally, the best place to start would be looking at the closest star to us. As you may know, stars are formed when gas and dust clouds in space collapse under their own gravity. But not all the material in these clouds reaches the critical mass needed to trigger nuclear fusion. In such cases, planets that cannot produce their own energy are also formed in the same environment. So understanding how stars form also tells us that planets and moons usually form along with stars. That means almost every star we see in the sky should have at least one planet orbiting it. Based on this, if we were to observe the closest star to us in detail, using the right techniques, discovering a planet around it wouldn't be all that surprising. So let's start with the closest star to our solar system. It's called Proxima Centauri, located about 4.2 light years, or roughly 40 trillion kilometers, away. At this point, a question naturally comes up. If it's the closest star to us, why does it appear so dim? Because Proxima Centauri is a red dwarf star, specifically an M-type red dwarf. Red dwarfs are the most common type of star in the universe. But they're also small and emit very little light. Due to their smaller size and mass, red dwarfs are cooler and burn their fuel slowly, unlike massive stars. In fact, if Proxima Centauri continues its fusion process at the current rate, it could keep shining for several trillion more years. So we can say red dwarfs are quiet or calm stars, relatively speaking. This calmness makes red dwarfs particularly interesting when it comes to the possibility of life in space. To talk about life on a planet, that planet needs to lie within its star's habitable zone. Not too close, not too far. Within this zone, liquid water could exist on the surface, which is key for life as we know it. Since red dwarfs are cooler stars, their habitable zones are much closer to the star itself. And that's exactly what we see with Proxima Centauri b, a planet discovered in 2016 orbiting Proxima Centauri. This exoplanet completes one full orbit around its star in just 11 days. That means a year on Proxima b lasts only 11 days. The planet orbits just 7 million kilometers away from its star. For comparison, the closest planet to our Sun, Mercury, orbits at about 58 million kilometers. Yet despite being so close to its star, Proxima b may still be habitable. That's because Proxima Centauri is much cooler than the Sun, with a surface temperature of just 2,800 degrees, compared to the Sun's 6,000 degrees. One of the key factors in determining Proxima b's habitability is its mass. Generally speaking, the more massive a planet is, the thicker atmosphere it can hold. An atmosphere is critical for habitability. It regulates climate, protects from radiation, and supports liquid water. Proxima b has a mass of about 1.27 times that of Earth. This suggests that it's a rocky planet with a solid surface and likely an atmosphere. But now, let's pause for a moment. I've just given you details about Proxima b's size, mass, and atmosphere. Yet we don't even have a single photo of this planet. Even the Hubble Space Telescope only managed to photograph Proxima Centauri, the star, not the planet itself. So how do we know so much? Proxima Centauri b was discovered using a technique called the radial velocity method. Let me explain it in simple terms. All planets and stars in a system interact gravitationally. While stars are far more massive, planets still exert a small pull on them. This causes the star to wobble ever so slightly as the planet orbits. With red dwarfs being less massive than stars like our Sun, that wobble becomes more noticeable. As the star moves slightly toward us, the light it emits is shifted toward the blue end of the spectrum, blue shift. As it moves away from us, the light shifts toward the red end, red shift. This is known as the Doppler effect. By analyzing these shifts, astronomers can detect the presence of a planet. That's why it's called the radial velocity method. The measurement is based on changes in the star's velocity relative to Earth. This method also reveals the mass of the planet, because the stronger the wobble, the more massive or closer the planet must be. So, by applying this method, we can say that Proxima b is likely in the habitable zone, has a rocky surface, is slightly more massive than Earth, and has an atmosphere. All of this makes Proxima b the closest potentially habitable planet to Earth. But of course, nothing is perfect. There are also some major challenges to habitability. First is a condition called tidal locking. Because Proxima b orbits so closely to its star, only one side always faces the star, while the other remains in permanent darkness. This may lead to one side being extremely hot, while the other is freezing cold. Still, if the planet has a thick atmosphere, winds might help distribute heat and balance the climate. But tidal locking isn't the biggest threat. The real danger comes from stellar flares. Despite being small and relatively calm, active red dwarfs like Proxima Centauri can release powerful plasma bursts. The same kind of solar flares we sometimes experience from our sun, but potentially more intense. No star is perfectly stable, not even our sun. The sun has an 11-year solar cycle where sunspots and flares increase and decrease. If Proxima Centauri emits strong flares, they could strip away the planet's atmosphere. Unless Proxima b has a strong magnetic field to protect itself, like Earth does. Unfortunately, we don't yet know if Proxima b has a magnetic field. Now, everything we've discussed so far relates to habitability, not necessarily the presence of life. There's a big difference. We've only asked, could we live there someday? And based on all the known criteria, surface, atmosphere, mass, distance, yes, it seems possible. If we were able to go there, we might find oceans, rivers, or land protected by a stable atmosphere. At least that's what the science suggests. For now, Proxima Centauri b might truly be the closest potentially habitable planet to Earth. But here's one last question. If we really wanted to go there, how long would it take using today's or even future technology? And could we actually make it?